Okay, so now we're going to solve the classic Crackme 0x100 peak CTF problem. It says that a classic Crackme, find the password, get the flag, binary can be downloaded here. So crack the binary file locally and recover the password. Use the same password on the server to get the flag. Additional details will be available after launching your challenge instance. So let's first download this. So let's okay, so we cannot open this, so let's go to the downloads folder where it's currently should be downloaded. There it is. So let's open the terminal here. Let's check. It's there. Let's give it the executable permission first. So let's do that. So if I do that, it's now green instead of the gray or white, whatever. Alright, now let's try to see what kind of file it is. So it's an ELF 64-bit LSB executable, not stripped. You could check for the strings in here as it's not stripped. So let's try that. Okay. Strings. Let's try to shorten it because there could be a lot of things that can come when I do strings. So we can see a lot of function calls and some code, and also the enter the secret password and then pick a CTF flag. Okay, so let's try to run this file now. Okay, so enter the secret password. So let's enter any kind of password first. So it says failed. Alright, let's try to open this in Ghidra and see what it actually has. It takes a bit of time. Okay. Just somehow it didn't get added here. Okay, let me add it manually. Okay. Okay, let's open it up. And let's analyze it. Okay, so inside the functions, let's check the main. So there's a lot of variables declared here. These are hexadecimal values, which has a character value. Okay, and then this, the print statement. Alright, and then there is this for loop here, which is running some kind of it's modifying some values, local 28. Okay, so and then it checks and compares the memory, and if it's the same, it gives us the flag. Okay, so this could be a kind of an encryption algorithm, which is encrypting, I'm guessing, our input, which is scanned here, and then it's comparing it with some hard-coded locally stored string. Okay, so what we can do is we can generate a string that would go through this encryption algorithm and then become such a string which would be equal to the hard-coded algorithm. And by the way, I know so much because if I copy this here and go to the compiler here, doc bolt, I just need the Ghidra and hex race. So if I just paste it here, okay, so let's browse this. I guess I have to browse it. Let's open it here. Yeah, so it gives us the Ghidra code that we saw in our Ghidra, and also it gives us the hex race. Now, in the hex race, you can see that it is much more easier and shorter to read, and you can see that there is a hard-coded string here. I have already done this, so I know it's a hard-coded string which is being compared later on, and then gives us the flag. And locally it just gives us a sample flag, but on the server, which we will run later, it will give us the real flag. So what we actually have to do here is take this whole while loop or whatever loop here, which is doing the encryption on our input, and we have to take this string as well, and we have to write some kind of an reverse logical encryption or decryption, actually decryption code, which will take in this string and convert it into such a value which will then, if we pass through the same function again, encryption function again, it will generate the same string, which will then be compared, and we will have our flag. Now I could go line by line and decrypt this, I mean reverse the logics, but it's much easier to just use a tool like ChatGPT and then use it to generate the decryption algorithm. So it has done it here already. So the reverse string, according to ChatGPT, is this one. So if I just copy this here, this should be the decrypted ciphertext, which we, if we pass through this encryption algorithm again, will give us or generate this exact string. So which will then be, if compared again, will be true, and then give us the flag. So let's see if it's true or not. So let's come here and let's run the program again locally on our disk, and let's paste that code. So you see we get a success. Now we gotta do the same thing, but on the server, which is running. So let's launch the instance. Let's copy this, and let's go to our terminal, and let's paste it here and connect to the remote server. Now we have to input the password, so let's secret password. Let's grab that string. By the way, we generated this string with the string which was hard-coded in the file. So this is something that was already inside the we're gonna be able to see it here. You're gonna be able to see it here. So it was hard-coded here. So we basically took this string, sent it through a reverse logical algorithm of this while loop, which created another string, and now if we pass that string to this encrypted encryption algorithm or while loop, it will generate the same string. It's basically doing the reverse of it. So if we do this and let's go back to the terminal and let's paste it in, should give us the flag. Here we go. So let's copy this and let's paste it here. Okay, sorry for that. Let's copy this and paste it here. Okay, and let's submit, and we solve the problem.